This talk was initially called climate realism, but that phrase has apparently been hijacked by climate change deniers, so we'll call it instead climate pragmatism. What is climate pragmatism? It is based on practicality and flexibility in addressing the serious threat of human-caused climate change. Pragmatists also view the climate change threat as being one whose future seriousness is very uncertain, therefore, they embrace a wider range of possible solutions than normally favored by most environmentalists. Let's expand a bit on the three central ideas of climate pragmatism. First, the threat of human-caused climate change is very serious, as spelled out in reports issued by the IPCC. Second, although the science behind climate change is very solid, many aspects of its future impact are very uncertain. The pragmatist, therefore, believes that the action needed to address these threats should depend on their seriousness as it unfolds, and they do not consider it realistic or desirable to set arbitrary deadlines to reduce global emissions to zero. You are very likely familiar with this graph showing how the world's average global temperature has varied since 1880. Zero on this graph is the average temperature over the period 1901 to 2000, and it is slightly higher than the average temperature in pre-industrial times. The most striking feature of the graph is the steady rise beginning around 1980 to the present. Based on the most recent available data, the planet is now about 1 degree Celsius or 1.8 degrees Fahrenheit above the average pre-industrial temperature. In fact, apart from small fluctuations, the rate of warming can be seen to be a nearly constant 1 degree Celsius in 40 years. Some deniers of human-caused climate change point to the sun as the likely culprit of steadily rising temperatures. But has the sun really been emitting slightly more energy in recent decades? Here we see in blue a graph for the sun's output over time and in red a graph for the average global temperature. For clarity, the sun's output has been averaged over continuous 11-year intervals. Without that averaging, you can see the effect of the 11-year sunspot cycle on the yearly output of the sun as the very faint blue curve. But with the 11-year averaging, we see from the dark blue graph that the sun's output has hardly changed over time. What about the most recent 40 years when global temperatures have been rising? During this time the sun's output has been falling, so there's no way the sun could be responsible for steadily rising global temperatures over recent decades. Nearly all climate scientists believe that the primary cause of the steady rise in global temperatures over the last 4 decades has been due to the greenhouse effect. The first warning about the greenhouse effect causing climate change goes back to 1896. At that time, Swedish scientist Svante Arrhenius noted that fossil fuel combustion and the CO2 emitted would eventually result in enhanced global warming. The basic idea is that carbon dioxide is transparent to visible light but opaque to infrared. Thus, the presence of CO2 in the atmosphere allows the sun's warming rays to reach the Earth's surface unimpeded and heat it up. The heated planet then will emit more infrared radiation to space, but the outgoing radiation will be blocked by the CO2. Clearly, the extent of the blockage and the amount of surface heating depends on the amount of CO2 in the atmosphere, just as Arrhenius said. Here is a graph showing the steady rise in CO2 concentration in the Earth's atmosphere. No matter which nation emits the CO2, it gradually spreads around the globe, and it stays in the atmosphere a long time. The annual wiggles in the graph are due to the annual growth and decay of vegetation leading to absorption of CO2 followed by its emission. Note that the current concentration is a bit over 400 parts per million, or in other words, only 0.04%. That might not sound like much, but it is enough to block much of the infrared radiation emitted by the warmed Earth. CO2 is not the only greenhouse gas, but it is the main one we worry about. Methane is an even more potent greenhouse gas, but it stays in the atmosphere only around 12 years compared to CO2, which hangs around as long as 1,000 years. It is interesting to compare present-day CO2 levels with levels found during much earlier times. In this graph we see the famous hockey stick plot. The very abrupt rise in the most recent century brings us to roughly twice the level found in the last 10,000 years. The measurements made for thousands and even millions of years ago are based on an analysis of the gas bubbles trapped in ice cores found at different depths in Greenland and Antarctic ice, and the age of the bubble can be inferred from its depth. Why is it so hard to reduce emission of CO2 into the atmosphere? The problem is that so many human activities involve consumption of fossil fuels, namely coal, oil and gas. Many nations have started a transition away from fossil fuels, but the shift takes time. In addition, while some nations have begun the shift away from fossil fuels years ago, the world now emits more CO2 than ever. A second reason it is hard to deal with climate change is that humans have evolved to cope with immediate threats, not slowly worsening ones revealed by data and science. Finally, despite all the evidence to the contrary, many people in the United States and elsewhere believe that climate change is not caused by humans. Virtually all the reasons why some people disbelieve in human-caused climate change can be shown to be dead wrong, and you can find many websites debunking them. The best of these is by John Cook, an Australian researcher at the University of Melbourne, whose Skeptical Science website debunks 218 arguments by climate change deniers. Listed below are the top 3 of these spurious arguments, the most common of which is that very much larger temperature changes have occurred on Earth before humans were around. If that's true, why are we getting all excited by a mere 1 degree Celsius warming in recent decades? This argument may sound persuasive, but like the other 217 arguments on Cook's website, it is based on a seriously flawed idea. Let's take a look at what geologists have found for ancient global temperatures before humans were around. These are found using those same ice cores they used to find atmospheric CO2. The 0 on the temperature scale here is an arbitrary choice since we are just interested in temperature differences. Notice the enormous natural temperature fluctuations shown in the graph. These fluctuations dwarf the 1°C rise seen in the last 4 decades. The steepest rise in this graph is probably indicated by the yellow triangle, which shows a rise of about 14 degrees Celsius in a time of about 20,000 years.
Give me a break. All we're talking about is a piddling 1 degree rise over 40 years. Before humans were around to blame, there were rises as large as 14 degrees.
That's the most common argument deniers give against climate change being human-caused. But this argument ignores the time scale over which the temperature is changing. In the distant past it rose 14 degrees Celsius over a time of 20,000 years, which is equivalent to 1 degree C in 1400 years. But the present rise of 1 degree took only 40 years. Therefore, the present rise is 35 times faster than the ancient one, and so it is very unlikely to be natural. One other claim made by climate change deniers is that an increased global temperature is on balance a good thing. Now, there are indeed some positive effects to increased temperatures. Just to name 3, CO2 is a fertilizer and promotes growth for certain plant species, human deaths due to extreme cold would be reduced, and the Arctic might become ice-free, which would be a boon to shipping. But, the idea that climate change is on balance beneficial is wrong. As the Skeptical Science website shows, the negative effects of global warming are far more extensive than the positive benefits. Although nearly all of the arguments raised by climate change deniers are erroneous, those who accept the reality of human-caused climate change are also guilty sometimes of making erroneous arguments. One example is that since temperatures in the distant past were closely correlated with CO2 levels, that shows how the greenhouse effect was the cause of ancient rising temperatures. This claim confuses cause and effect. Most likely, rising temperatures in the distant past were the cause, not the effect of rising CO2 levels. You observe this effect in action every time you watch a glass of soda lose its fizz when it is taken out of the refrigerator. As the soda warms up, it releases CO2 to the atmosphere, much as would happen to CO2 that had been dissolved in the world's oceans. Like many dynamical systems, the complex climate system might have tipping points that would occur when a certain temperature rise is reached. What exactly is meant by a tipping point? Consider the example illustrated here for a system that literally tips over once enough ice is melted. In that respect, it closely mirrors the global climate system, which might also revert to a dramatically different state once enough of the planet's ice melts. It is clear from this artificial example that once a tipping point is reached, the change in the system can be not only dramatically different, but also sudden and irreversible. the first two tipping points would be when the West Antarctic and Greenland ice sheets start melting at a rate that will lead to their eventual disappearance. How much would the temperature have to rise above pre-industrial times to reach those first two tipping points? The latest estimate is between 1 and 3 degrees Celsius according to the IPCC. But bear in mind that the temperature rise to date is already 1 degree Celsius. So how long do we have before the Earth's climate reaches its first two tipping points, namely the melting of the West Antarctic and Greenland ice sheets becoming unstoppable? Obviously, if the tipping point is 1 degree, we have already reached the tipping point. If it is 2 degrees, we'd have 40 more years left, and if it's 3 degrees we'd have 80 years. Clearly, the implications for the future are drastically different if the true tipping point is either 1, 2 or 3 degrees Celsius. This simple calculation illustrates one aspect of the very great uncertainty about the future impact of climate change. In a worst-case scenario, if the Greenland and Antarctic ice sheets were to fully melt, sea level might rise by an astounding 200 feet, and lower Manhattan might look something like this picture. But, for this situation to occur, the warming would need to reach the tipping point of the East Antarctic ice sheet, which is between 5 to 10 degrees Celsius. In addition, after that tipping point were reached, the Antarctic ice sheet would not melt completely for at least 10,000 years, and possibly much longer. That's because the rate of melting of the ice sheets and the rate of sea level rise both remain extremely uncertain. That uncertainty in sea level rise is mainly due to the wide range of computer models used to predict it. Here we see the projected increase for 4 models. The low estimate to sea level rise by the year 2100 is found by simply continuing the present trend. This yields only 0.2 meters, or about 8 inches. But the highest rise is 10 times greater. Many people believe that one should stress worst cases in situations of great uncertainty. But this approach risks developing either a fatalistic attitude or a waste of resources in preparation of a threat that may prove not nearly as bad as feared. Stressing worst-case scenarios in order to scare people into supporting efforts to combat climate change is also unwise because it will likely backfire. In contrast, when faced with large uncertainties, a climate pragmatist would prefer a wait-and-see approach, where the remediation efforts evolves as the threat becomes clearer. But, of course, waiting too long is highly dangerous also. With climate change we are like the proverbial frog placed in a pot that is slowly heated. If the heating is gradual enough, the frog does not know when to take the drastic action of jumping out of the pot before it is boiled alive. Apparently real frogs are not so stupid. Are we? The main thing that needs to be done to cope with the climate threat is to shift our energy usage away from the 3 fossil fuels of coal, oil, and gas, which emit CO₂ during their combustion. Renewable energy sources, including hydropower, solar, wind, geothermal, and tidal power all are virtually inexhaustible, but some of them do vary over time, which requires efficient means of energy storage. At present only 12.4% of United States energy is based on renewable sources, and it has been increasing at 0.5% per year. If that rate of increase were to continue, it would take another 176 years before all the United States energy was from renewable sources. The world's leader in the amount of renewable energy generated is currently China, whose percentage of energy from renewables is growing significantly faster than the United States. Unfortunately, China also emits more CO₂ from fossil fuels than anyone else. Although China is the world leader in the largest amount of renewable energy usage, it is very far from the leader in terms of the percentage of its energy from renewable sources. Here we see the list of countries which generate at least 90% of their electricity from renewable sources. It is interesting that 5 of these 12 nations are in the continent of Africa. The reason for this surprising result becomes clear when the renewable energy sources are disaggregated into specific types. In all but one country, the largest renewable by far is hydropower. Africa dominates in having the highest percentages of renewable electricity because of its abundant hydropower, which is expected to double in the coming decade. Hydropower has the great advantage of having a readily adjustable output. Thus, it can be used to supply electricity whenever needed, and it makes a great complement to solar energy. During daytime, when the solar cells produce more energy than needed, pumps can store energy by raising water levels in a reservoir. That energy is then later withdrawn during nighttime, when solar cells do not operate. Pumped storage hydro is the most important energy storage mechanism in use worldwide. A useful metric to see how much progress the nations of the world are making in moving away from fossil fuels is the increase in the percentage of their electricity from renewable sources. For the decade 2010 to 2020, the top 10 countries in the world in ranked order are listed here. Hats off to Uruguay. What about the world as a whole? As can be seen from this graph, world CO₂ emissions continue to rise at an ever-increasing rate. Beginning around the year 2000, emissions from Western nations have modestly decreased. However, the world total has been driven by rapidly rising emissions from China. While some people may choose to reduce their carbon footprint regardless of what anyone else is doing, others may not be willing to make changes to their lifestyle when emissions in China and some other nations keep rising. Of course, the Chinese might note that their emissions per person are still roughly half those in the US. Still, until China stops adding new coal power plants, that nation will be the one most responsible for the world's ever-increasing CO₂ emissions. In 2015, 196 nations met in Paris and agreed to hold the increase in the global average temperature to below 2 degrees Celsius. But, such agreements are meaningless without actions, particularly actions by the nations that emit the most CO₂. While phasing out fossil fuels for generating electricity is very important, the most effective actions are those that can be accomplished easily and quickly, namely the low-hanging fruit. A top priority here would be improving energy efficiency in buildings, transportation, and industry, which save both money and energy. More sustainable practices in agriculture and forestry is another low-hanging fruit. For example, livestock emit significant amounts of methane that could be greatly reduced by a cheap dietary supplement. Finally, phasing out coal, while it cannot be done quickly or easily, is particularly important in reducing emissions, given that it accounts for almost half of all CO₂ worldwide. Coal also emits twice as much CO₂ as natural gas plants, and it causes millions of deaths annually, especially in China, where many households still rely on small coal stoves for heating. When aging coal plants are phased out, they have been replaced by natural gas plants, renewable energy plants, energy storage facilities, and nuclear power plants. Replacement of coal by natural gas is particularly controversial since both are fossil fuels, but natural gas has only about half the CO₂ emissions as coal and is far less damaging to human health. Natural gas is also a natural ally to renewable sources, since it can make up for the latter's variable output over time. Although most people who are concerned about the environment are also very leery of nuclear power, these power plants do offer a way to reduce CO₂ emissions almost to zero, and like natural gas, they can produce steady baseload power during any times when it is needed. In addition, the newer generation of nuclear reactors is expected to be much safer than those currently in use. As a result, some environmentalists have embraced nuclear as a complement to renewable sources. According to the website for environmentalists for nuclear energy, environmental opposition to nuclear energy is the greatest misunderstanding and mistake of the century. Let's compare the health impact of nuclear power plants to those powered by coal, which is still the dominant way electricity is generated worldwide at 35% compared with only 10% of electric generation for nuclear. This comparison is based on the estimated number of fatalities caused by various energy sources on a per unit energy generated. Even taking into account the two major nuclear accidents, at Chernobyl and Fukushima, the data show there are around 350 times as many deaths from coal than nuclear, with the majority of these being due to air pollution. In addition, while nuclear is not a carbon-free energy source, CO₂ emissions from coal plants are roughly 200 times greater than those from nuclear plants. Among the new generation of nuclear reactors, the most interesting type are the small modular reactors. SMRs generate much less power than the reactors now in use, and they generate much less nuclear waste as well. SMRs are inherently safer than earlier reactor types because they run with very little maintenance, and their passive safety systems cause them to automatically shut down without any operator intervention if they start to overheat. In contrast to large reactors, which may take a decade to construct, SMRs can be ordered from the factory as needed and delivered by truck. They can be thought of as very large nuclear batteries that can back up renewable energy sources. SMRs are being developed in 17 nations, including the US. The particular design shown is the so-called pebble bed reactor. This reactor is continually refueled as used fuel pebbles exit the bottom and fresh fuel pebbles drops in from the top. Current reactors rely on the splitting of heavy nuclei, that is nuclear fission, to generate energy. Scientists have long been exploring power generation by nuclear fusion, that is the combining of light nuclei, which is how the sun generates its energy. To ignite the fuel in a nuclear fusion reactor, it would need to be heated to temperatures of millions of degrees. One way to do this uses many laser beams converging at the same instant on a small fuel pellet consisting of two forms of hydrogen. In December 2022, researchers first created more energy output than was initially present. But, despite this breakthrough, most experts put the development of a commercial fusion reactor in the 2060 or 2070 decade, too late to mean much for the climate change problem. If we think of our change in Earth's climate as an experiment, then the question naturally arises, what happens if our experiment messes up our home planet beyond all repair? Is there a planet B to which we could migrate? Some, for example, have suggested modifying the climate of Mars to make it habitable. These ideas may make for good science fiction, but no climate pragmatist interested in realistic climate actions could take them seriously. There simply is no planet B. While there is no planet B, there is what we might call a plan B for dealing with climate change. The conventional solution, what we can call plan A, is to switch from fossil fuels to renewable sources of energy as rapidly as possible. This switch is important, but as we have seen, the world's CO2 emissions continue to rise, and we may not be able to complete the switch in time. Plan A, therefore, needs to be supplemented by all the other ways to deal with climate change. The boxed items listed are highly controversial, but they can have a substantial impact. Geoengineering, the last item on the list, includes using a sunshade sprayed aerosol to lower very slightly the amount of sunlight reaching Earth. This one, all on its own, might end the threat of global warming. And since aerosols occur naturally with volcanic eruptions, they might well prove effective without serious side effects. Regrettably, all the boxed items are unwisely dismissed by some environmentalists because they are seen to prolong reliance on the fossil fuel industry, or else for nuclear because they involve a scary technology. Let's consider one of these items a bit more, namely carbon capture. The world's forests remove around 3 billion tons of CO2 annually, an amount that continues to decline because of deforestation. While planting a tree is good for the environment, it turns out that planting an artificial tree is even better. Artificial trees can remove a ton of CO2 per day and through the magic of chemistry produce sodium carbonate. Over the course of a year, they can remove about 1,000 times as much as real trees do. On the other hand, to remove all the CO2 emissions in a given year would require 100 million of them. This possible solution to the climate problem is also as yet unfeasible given the high cost of artificial trees, which would need to be reduced at least tenfold. Artificial trees have one more big drawback, namely disposing of the sodium carbonate that they build up, since it would be far too costly to go around to each one and collect it. A far simpler scheme would be to vacuum up the CO2 at a single location, preferably close to a place, such as a coal power plant, where it is very concentrated. After the CO2 is mixed with water, the mixture slowly becomes stone as it cools in underground caverns, as this cartoon suggests. One such plant was completed in Iceland in 2021, which removes 4,000 tons of CO2 per year, but that is a mere 1/millionth of what is required for all global emissions. Clearly, some new innovations are needed. In order to stimulate the search for them, a privately funded $80 million prize is scheduled to be awarded in 2025. It would go to the best carbon capture and storage technology that is shown to be capable of removing 10 billion tons of CO₂ annually by 2050, an amount equal to twice the world's annual emissions. Let's conclude with some good news on climate change, whose uncertain future seriousness could be much less than feared. For example, if the first tipping point in the climate system is 3 degrees Celsius above pre-industrial temperatures, we might have 80 years to complete the transition to renewable energy. Some renewables, in fact, are now cheaper than fossil fuels. Many countries are developing much safer small modular nuclear reactors, and a breakthrough in carbon capture might also greatly help. An aerosol sunshade might even end the threat all on its own. The uncertain rise in sea level by 2100 could be very small and give us ample time to adjust. Finally, even if the future impact of climate change were to fall into the worst-case range, it will still not be a civilization ender. Climate change is in marked contrast to the nuclear war threat, which could be upon us at any time. So, if your worry budget is limited, worry less about climate change and more about nuclear war.